Hi, I'm Art Baudo, a principal specialist at AWS in the EC2 core team. I'm joined today by Samantha Pham, a senior product manager in the EC2 core accelerated instance team. We'd like to thank you for joining us today to talk about the newest addition to our GPU accelerated instance portfolio, G4ad instances. G4ad instances offer customers some of the best price per performance for a GPU instance. Today, we'll give you an overview of the G4ad instances. We'll do a few demonstrations showing you how to get started using G4ad, and also do a couple demonstrations using G4ad on some common use cases. Let's get started. AWS has built the broadest compute platform that powers some of the largest companies globally. While I show you this list of customers, it's really to give you an idea of our ability to scale. AWS is equipped to work with everyone from small startups to large multinational corporations. And we're a customer-centric company. At AWS, that means we develop and produce new instances, software, and managed services to meet customer needs. Today, we're going to talk to you about how you can leverage the GPU acceleration in the cloud. And we'll talk a little bit about how G4ad is the result of listening to customers such as yourselves and defining their needs in the cloud. So Amazon's EC2, also known as Elastic Cloud Compute platform, provides a true foundation to build your network and start leveraging the cloud. And it is typically the first step in a customer's cloud journey. Customers can start here, easily testing out the latest innovations from Amazon and get started fast. In addition, the breadth and depth of the offerings that AWS provides is not replicated anywhere else in the cloud. As we talk today about G4ad, I think it's worth discussing how an instance such as G4ad is actually built off of architecture customers will have familiarity with. G4ad uses AWS's Nitro-based system, which offers the industry-leading hypervisor and security support customers come to AWS for. G4ad actually incorporates CPU processors from AMD along with GPU accelerators. Those CPU processors we also offer in our compute-based instances. So customers who are familiar with the compute-based instances will see many similarities in the GPU offering. We'll talk more about the other dimensions of G4ad as Samantha and I dive deeper today. When I work with customers on utilization of GPU-based instances, one of the first things customers talk to me about is how their workloads are unique, and therefore they might not be able to migrate them from on-prem to the cloud. My first response to customers is that's why we make sure our cloud-based instances are flexible. And our cloud-based instances are made to accommodate a variety of different workloads. And we also offer systems that are simple and intuitive for customers to utilize. And you can migrate much of the work you do in your on-prem system directly to the cloud. The other advantage is that we have optimized that GPU experience and performance offering to you from multiple options for you to select from. And we have a full complement of support that is available for customers. Some of that is today, but we'll talk through and walk through how you can get started using the G4ad instances. If we look into compute-based instances from AWS, you can see this wide variety of instance offerings. Our instances are divided into a general purpose compute-based category, memory optimized compute, compute optimized, storage optimized, and accelerated compute. Today we'll be focused on the accelerated compute category of instances, specifically the G4ad instance, which I've outlined in white in this diagram. But in the diagram, you can also see all of the other AMD-based offerings throughout each of our compute-based platforms. And what I like about this is you can see our entire set of compute-based offerings here. AMD instances are easily identified because they have an A in them, just like G4ad, C5a, M5a, R5a. I'd like to now start talking a little bit about the relationship between AMD and AWS instances. AMD instances offer customers first cost efficiency. On G4ad, we offer up to 45% better price per performance than comparable graphics instances. So you'll save money without sacrificing performance. And you'll gain significant savings, so you'll be able to reduce your overall costs. G4ad is available in many regions and availability zones throughout the AWS system. It's ready for customers to take advantage of it right now. And as we've said before, we're responsive to customer needs. So reach out to us about availability if you have any questions. And then ease of migration. Customers who are familiar with the x86 architecture and industry standard APIs such as DirectX, Vulkan, and OpenGL will benefit from the AMD G4ad instances. You can simply port your software over to these G4ad instances. In addition, AMD offers a full suite of applications that will enable you to make the migration over to AMD-based GPU instances. As we go through our webinar today, we'll talk more about some of the specific applications and software that AMD offers that will make it easy for you to migrate your workloads over to G4ad instances. I've personally seen customers be able to migrate instances in very fast time. So customers ask me about the AWS partnership with AMD. AWS launched our first AMD instance in 2018. We have had an AMD-based instance launch every year since, including the launch of C5a, C5ad, and G4ad in 2020 alone. AMD instances power 8 instance families already. We'll do a quick review of the instances on the next slide. Today, we offer C5a, C5ad, M5a, M5ad, R5a, R5ad, T3a, and G4ad. These instances use 2 families of AMD processors, the AMD first generation Naples, also known as EPYC, AMD EPYC 7001 series, and the AMD second generation Rome processor, which is known as the AMD EPYC 7002 processor. Here's an overview of each of the AMD-based instances. Starting with our general purpose instances, which offer 4:1 memory to vCPU ratio using a 2.5 gigahertz clocked AMD processor. The memory optimized R5a instances offer an 8:1 memory to vCPU ratio and operate at the same clock speed as M5a. The compute optimized instances have a 2:1 memory to vCPU ratio and operate at a clock speed of up to 3.3 gigahertz. Remember from the prior slide that the compute-based instances are on the second generation EPYC 7002 processor. Our final compute-based instance is the T3. This is also known as our burstable instance. The T3 instance, like the M5 and R5 instances, is available on the EPYC 7001 or Naples generation processor. Finally, today, we're going to focus on the G4AD instance. The G4AD instance shares the same CPU as the compute-based optimized instance, AMD's Rome-based architecture, and it adds 4 AMD Radeon Pro GPUs. I'm going to let Samantha take it over from here to talk a little bit more in depth about those G4AD instances. Samantha?
Thanks, Art. We broadened our AMD portfolio by announcing our first AMD GPU-based instances last December at reInvent. As Art mentioned, these G4AD instances use the same second-generation EPYC processor, also known as Rome, that you see in our C5a instances. As a reminder, those offer up to 3.3 gigahertz of clock speed. We've added to that processor AMD Radeon Pro V520 GPUs. These AMD Radeon Pro V520 GPUs offer customers such as yourself up to 40% better graphics performance at a 15% lower cost versus our comparable instances for graphics workloads like game streaming and remote workstations, which we'll dive into later. This combination of higher performance and lower cost offers customers like yourself up to 45% better price performance versus our comparable instances. Now I want to dive into a little bit about our AMD Radeon Pro V520 GPUs that power the G4AD instances. So we'll talk about some of their key features and specifications. The AMD Radeon Pro V520 GPUs come with 36 compute units and 8 gigabytes of high bandwidth GPU memory, as well as a peak engine clock speed of 1600 megahertz. These GPUs are built using AMD's RDNA architecture, which is designed to render your graphics at high speeds with hyper-efficient, low latency communication between the GPU and the CPU. With these instances, we offer 3 different instance sizes so that you can right size your instance to your compute needs. The 3 sizes we offer are the 4x large, the 8x large, and the 16x large, which give you a range of 1 to 4 GPUs, depending on how much GPU compute power you need for your workload. They also offer up to 64 vCPUs and 256 gigabytes of memory. So like our general purpose instances, they also have a 4-to-1 ratio of memory to vCPUs. We're going to take a quick look at some of the targeted industries for G4AD. While these are some great examples of how you can use G4AD, this is not exhaustive, and there are other industries where you can find great use for the G4AD instances. First, we'll start with the gaming industry. Customers like yourselves might find that you want to use the G4AD instances for game development like character creation or scene creation, as well as game streaming. Other customers might find themselves in the architecture, engineering, and construction industries, which is great for GPU workstations for computer-aided design or computer-aided manufacturing. In addition, customers in the media and entertainment space can find that G4AD is great for workstations that they need for visual effects and animation. For those of you in the healthcare and life sciences industries, you'll find that the GPUs for G4AD offer great power for molecular visualization. And for those of you in retail, you'll find that the GPUs found in G4AD offer great power for rendering interactive content for your end users. And lastly, customers in the energy space will find that our powerful G4AD instances are great for seismic visualization and workstations. Some of our targeted use cases for these G4AD instances include remote workstations. As mentioned previously, these are great for graphics intensive workloads like game development, creating animation and visual effects, and editing live action videos. In addition, the G4AD instances are great for pixel streaming, which can be used to stream premium games or 3D content or even live virtual events to end users on any device at any location. And lastly, they're really great for rendering as well. With the G4AD instances, you can render photorealistic 2D and 3D images. So now let's dive into some of these use cases for G4AD. The first use case we'll look at is remote workstations. With remote workstations, using the cloud is great because you get scalable resources, meaning that you can provision your workstations as needed on a per project basis. So as you're reaching a deadline, you can add more employees to work on the deliverables and scale up on your workstations. And once you finish working on that deliverable, you can scale back down and pay for only what you need. In addition, these instances give you the flexibility to scale the resources on your workstations up and down as needed. So if you're doing a more graphic intensive project, then you can scale up to 4 GPUs or all the way down to 1 GPU to optimize your costs. In addition, with workstations in the cloud, you have more data control because you can securely store your data in the cloud and stream only the encrypted pixels to your end user's workstation. And lastly, it's great for collaboration because you can centrally store the data in one place to remove any synchronization challenges from end users modifying locally stored versions of shared files. With remote workstations, we see a lot of different types of graphic workloads that will benefit from the G4AD instances, like 3D computer-aided design or building information modeling or architectural visualization that a lot of customers do that are in the architecture, engineering, and construction industries. Applications like Autodesk 3ds Max and Revit, AutoCAD, PTC Creo, and SolidWorks are great for those kinds of workloads and are supported with the G4AD instances. Other examples of graphics workloads for customers in the gaming industry are game rendering or game development through character creation and scene creation. For those customers, we support many applications like Unreal, Unity, Cinema 4D, and AWS Lumberyard. And as a last example, for those customers in the media and entertainment industries, they can use G4AD for remote workstations for things like compositing, animation, painting, and rotoscoping through applications like Blender, Autodesk Maya, and VRED, Houdini, and DaVinci Resolve. Now we're going to run through a quick demo about how you can use G4AD instances for your remote workstations. Through this demo, we're going to be using Nice DCV as our remote display protocol, which comes at no additional cost with your EC2 instances. When we do our content creation, we're going to use DaVinci Resolve by Blackmagic Design. While that's loading, I just want to quickly point out that we are using a G4AD.16x large instance in our North Virginia region. And so now that the application is loaded, we're going to select on our G4AD demo project, which is just a simple video clip that we're going to play with here. And so as we scrub through the content of the video, you'll see that we get really great instant updates. And as we play the video in real time, you can see that we have great feedback at a steady 60 frames per second. If you look at the video playing in the top and the timeline at the bottom, you'll see that there are no drop frames even as we quickly scrub through the timeline. Now we're going to do some quick color correction to show you the editing aspect of this. So over here in the color panel, we'll adjust the curves to really increase the contrast and make a more dramatic image. And then we'll also edit some of the gamma inputs as well. And so now as you scrub through this video, you'll see that all of the color correction has been applied to each and every frame of the video. And as we play it back with that color correction, you'll still see a really great and steady 60 frames per second rendered as you play. So now that we've demoed that, we're going to reset the color back to its original settings, and then we'll skip back over to the edit window. So as we're here in this edit window, you'll see that as we continue to play with the timeline, the video is still very consistently rendered at 60 frames per second without any dropped frames. And so it gives you a really great experience as a video editor working on a workstation with G4ad. And so it's worth noting that with G4ad and nice DCV, you can provision a workstation with 2 monitors of 4K resolution. And so if we scroll over to the source, you'll see that these videos are indeed 4K videos that are rendering on your workstation with the very, very steady 60 frames per second. So the second use case that we're going to dive in today is pixel streaming. So with the G4ad instances, we offer great support for pixel streaming, which allows you to stream your graphics content to any device anywhere. You can stream your content to smartphones, tablets, computers, game consoles, etc., to wherever your end user is, as long as they're connected to a broadband network. In addition to the ability to stream to your users anywhere on any device, similar to what you see with remote workstations, you can scale your resources up and down as needed. So if you have a live event where you're streaming a 3D virtual space to your end users, you can scale up your resources and then scale back down when the event ends to make sure that you're optimizing your costs. In addition, you get the flexibility to configure your instances with more or less resources like GPU, vCPUs, or memory to match your content's complexity and make sure that you have the compute power that you need to render those graphic scenes for your end users. With pixel streaming, we see a lot of great use cases from customers where they're streaming games directly to their end users, or live virtual events where end users can come in, walk through virtual scenes, and even interact with other end users, as well as do training simulations or make 3D configurators for things like car shows and purchasing cars. With G4ad and all of these pixel streaming use cases, we can support up to 4K resolution with a steady 60 frames per second, as you saw in the last demo. We also offer up to 25 gigabits per second of network bandwidth, which allows you to stream your video and your content to your end users with really low latency. In addition, we support rendering engines like Unreal Engine to render your 3D content for your end user. And lastly, we support things like services like Amazon Elastic Kubernetes Service, also known as EKS, which allows you to deploy your servers at scale for these streaming use cases. Now we're also going to dive into another demo, which show how you can use pixel streaming for your customers. In this demo, we're using nice DCV again as our remote display protocol. With nice DCV, we're streaming some 3D content using Unigen's superposition benchmark. This benchmark uses Unigen's rendering engine, which has an underlying API of DirectX 11 to render the scene. While this specific engine is using DirectX 11, we also support DirectX 12, Vulkan, and OpenGL for rendering engines. With nice DCV, you'll see that we have GPU accelerated video encoding, which gives you really crisp and clear visuals to display to your customers and stream to your customers at a steady frame rate of 60 frames per second, which you can see in that corner graph there. You can see that the consistency of the video is great for your customers, and they'll have a good user experience regardless of the complexity of that video that you're streaming. And so now I'm going to hand it off to Art to go over the last use case for G4ad.
Hey, thanks, Samantha. So the last use case we're going to talk about is rendering benefits. So Samantha's done a great job here where we did some demonstrations of using G4ad for applications and pixel streaming and working. So I'm going to talk a little bit more about the rendering benefits that you can get. Rendering we have here, we talk about in three categories: visual effect rendering, product design. So if you're on a team designing a specific product, you need high quality renderings to be able to exchange with the team and to make sure that you have this rendering produced. And finally, architectural renderings, which Samantha alluded to earlier with the CAD and other designs. It's essential here to have this high quality rendering appearance here. So next, I'm going to talk about the applications that are specific to that rendering. So one of the things that AMD GPUs focus on is making sure that you have photorealistic images. Thing about visual effects, product designs, and architectural renderings is the need to have photorealistic images in order to make decisions about what you're designing, the visual effects you're applying. This is one of the things that crosses over to the G4ad engine here. They are powerful physical-based engines that offer this photorealistic images. They're also physically correct, which makes them ideal for people utilizing them in these architectural and design rendering ideas where the physicality of this is an absolute must. We balance this GPU to CPU ratio. We talked about that a little bit earlier. And then today we're going to talk and show you how fast the GPU is and also how accurate it is as we show through some of the examples here. One of the other elements that's key here for the G4ad is our usage of open source technology. This means that it's easy to obtain, free of licenses, and easy to use. The other thing is the application level support. AMD offers the AMD Radeon Pro Render Suite. The Pro Render Suite offers application support for Blender, Maya, 3ds Max, PTC Creo, Unreal Engine, and the USD Hydro Renderer Delegate. Next, I'm going to walk you through a demo on rendering here. So let's start the demo. I've already provisioned the workstation in this particular example. We'll start by running the example rendering workload. This is going to be Blender. It uses Blender 2.9, and it uses the 4 AMD Radeon Pro GPUs. This is a multi-GPU renderer, and you'll see we'll use all 4 of the GPUs here. A note that the Blender 2.9 is available to just download freely on the web, so you can also repeat this in your offices. We're going to use 4096 path trace examples with 8 light bounces. This is going to produce a 1440 by 1080 image. So it's going to take a few minutes for us to actually render the image on the screen for you. And while that does that, I'll talk a little bit more about remembering where we are in the G4ad instances. So as Samantha mentioned earlier, we have the support for up to the 4K resolution here. And a note as well about the GPUs from AMD. AMD is also in some of the console-based GPUs that you've probably seen and developers have worked with before, Xbox and PlayStation as well. As I look here, you can see how we're rendering on the screen. We'll fill this out with the content. As we slowly do, this is using, as I mentioned earlier, the path tracing examples here. We're going to finish out by filling out the right-hand side here, and then we're going to do some light adjustments as well. This is going to slowly kind of walk through this entire rendering here, and you can see how quickly this is happening, and also the quality of the rendering that we're doing here. We're just about finished rendering this here. And as you can see, we'll take another adjustment and a pass through, and this is where we increase and look at the light function as well in the rendering agent. So give it a couple more seconds here as we complete out the imaging here. So we have now the incredible detail that's available to you as well with the image here. And now that the rendering has completed, I just want to note that I sped this up for you. The actual video takes a little bit under 8 minutes to complete, which is pretty fast. Okay, so next thing I'd like to talk about is just getting started. You're probably looking at these videos, excited by G4ad. You've seen some of the demonstrations that we have, and the question as a customer is, okay, I'm interested in trying out the G4ad instances. How do I do that? That's simple. The G4ad instances are currently available in several of our regions globally: Northern Virginia, Oregon, Ohio, Canada, Ireland, Frankfurt, London, and Tokyo already. We also support a variety of software operating systems. So we support Windows Server 2016 and 2019. We support, of course, Amazon Linux too. And then we also support Ubuntu and CentOS. We've mentioned a few times about the open source APIs that we support. So we support DirectX 12, DirectX 11, Vulkan, and OpenGL just to get started. And then, as mentioned before, we can support up to 2 4K monitors per GPU. Remembering in our prior demonstration, I used 4 of the GPUs. If you'd like to learn more, I've included a website here for easy access. This includes information about the entire G4 family of GPU accelerators that's available. You can use that website to get more information and also to reach out to us and provide us with feedback and questions that you might have about the G4ad instances. I'd like to move on to talk about our partnership that we have. AWS has worked with multiple companies with remote display protocols. Today, I'm going to provide an example talking through NiceDCV and Teradici. AWS is pleased to announce that both NiceDCV and Teradici have published AMIs available in the AWS marketplace for G4ad instances. These AMIs will allow you to utilize the NiceDCV and Teradici remote display protocols on G4ad. AWS is committed to working with a variety of vendors to publish AMIs, and we look forward to announcing additional AMI support for G4ad as we go forward. You can see all of the AMI support in G4ad in the AWS marketplace, which I encourage you to visit. The next thing I'm going to do today, though, is to give you an idea of how easy it is to get started with G4ad. I'm going to walk you through using NiceDCV, using first Windows and then Linux as two demonstrations for you. Let's get started with the Windows example. I'm right now in Windows here. We'll click to launch the instances in the upper right corner of the screen here. And we'll use this and connect to a host name, and then go search for G4ad in the AWS marketplace. As we search for G4ad, we can see the NiceDCV AMI. As this comes up, you can see, as Samantha mentioned before, there is no charge for utilizing the NiceDCV image. Let's go all the way down and click on Continue. Once we do that, you can scroll down here, and because we search for G4ad, you'll see G4ad highlighted in the list of instance types. Today, I'm going to work on G4ad with the 16XL. So let's click on that and then configure the instance. As we go to configure the instance, I'm going to leverage this using Spot instances, as this is a simple to do for today. We'll then set up the IAM role to move forward here with the instances. I'm then going to change the storage. I'm going to put the storage site here as about 500 gigabytes. and we're going to move to the SSD GP3 for IOPS. Let's next add some tags. In this case, I'll be creative. You can create your own name. It's G4ad nice DCV is the configuration tag. After you do that, you're going to use the security groups that you would have. Click on the security group, and then we're going to configure that security group by checking the credentials, and we'll get ready to launch the instances. You can see we're now launching the instances here. It's going to request the spot instances. So it's going to give a second here in this case to request the spot instances. Now that the instances are up, we'll click on them to take a look at them. You can see there under instance state that it's currently pending. Now the instance is in the running state. Let's connect to the instance. We'll click on the RDP client. We're going to take a look at our password and use the key pairing element to actually sign up for the password, use the password. We'll decrypt the password here. Let's continue here, and we'll copy the public DNS entry. We'll use that here as the entry into nice DCV, and then we'll use our username. Usually, you use yourself as administrator. Once you've done that, copy your password over, and simply get started here and log into the nice DCV console. You can now see that we've actually launched the nice DCV console for Windows. Pretty simple, right? So the final thing I'd like to do demonstration-wise here is walk you through the nice DCV for Linux as well. So let me get started with the Linux side. We're also in the viewer here. We'll launch nice DCV, go down and scroll. We'll then select G4ad. We're going to do the same procedure, similar procedure here that we did prior to that. We're going to select the tags, update the memory here, and then we're going to select our own tag here. This time it's AMD GPU for Ubuntu because I'm going to use this using Ubuntu. We're going to then set up our security here. I have a little bit more security credentials here on this slide, but that's okay. It's the same thing. Going to then pair the key, launch the instances just as we did before, and you can see the instance is still pending. Don't forget to now, we will copy the public IP address here. You can copy that address, and we'll begin using that here. Now you can launch the console itself. This console has been launched, and let's walk through the steps as we launch through the console. The first thing you're going to do is you're going to want to set up the driver here in the instance. You're going to want to make sure that check the operating system for any updates. In this particular case, there is an update. And once you do the update, you'll reboot the instance. Once we reboot the instance, we're going to reconnect to the instance after reboots. After I reboot the instance, I'm going to install the latest AMD driver. You'll first have to extract the driver to do the installation. You'll extract the driver, and then you'll do the installation of the driver. You'll run the self-install script to do that, and then once again, we'll reboot the instance. We'll do a quick check to make sure the driver is actually working, and then we'll get prepared to look at the desktop. Once we do this, you'll note that we also have to install the AMF encoder here, which is a key step in this path here. Once we install the AMF encoder, we'll get ready to launch the desktop instance here. And that's what you're seeing right now. As we walk through this slowly here to be doing the build and progresses through the launch here, I will launch the nice DCV rendering engine, which will actually show us how nice DCV is using the GPU accelerator. What we're seeing right now is the launch into and the setup of the nice DCV Linux console. So most people, I think you probably know how to use the nice DCV Linux console. We also have an example on our Getting Started guide and for further instructions about the usage here. Give it one more second and we'll actually launch into the nice DCV console, which you can see here. You'll use the previously copied instructions and launch. And then right here, as we launch the console, the demonstration here, you can see that this is nice DCV rendering and it's showing the usage of the GPU. So I've provided you with two ways to get started here. We talked first about how to launch the G4 AD instances using nice DCV in Windows. And now we've shown you how to do this utilizing nice DCV for Linux as well. Given that, you can also use other ALMIs to get started and in Linux or in Windows here. And I just want to thank everyone for coming today to our demonstration and information about G4AD. I would like to encourage everyone to utilize our website as a resource for more information on the G4 family. And just a couple of kind of mentions again, remembering that G4AD is our newest GPU offering here. We have a 45% price to performance benefit here. And I encourage everyone to get started and try the G4AD instances out. And I look forward to connecting with you either virtually or utilizing one of our web tools. So thank you again, Samantha, for joining me today. And thank you for joining us.
Yes, thanks everyone for joining.